Hello, my name is Loose Goose, and today I will be sharing you a tutorial how to create this subtractive pipe 3D model. It is in intermediate level difficulty, so don't worry if you're not going to have great success at first, because for example, it took me half an hour to create this model first time, but a second time I created it in like 4 or 5 minutes, so practice makes perfect. Before we start the 3D modeling, we have to actually understand what are we making. And inspect the sketch that we are given and understand the technical things that we must create for it. So the first thing we can notice, it will be in 2 pieces and they will be joined together in 1 piece. So yeah, the most difficult part we can already identify, and that's what we should focus on, which is the tilted pipe, which is in 33 degrees and placed in specific distance from edges. What else we can see, it is that it's hollow and that our task is to create the mass of this part in grams. From this diagram we can see that it's totally symmetrical from the top part, and from the side we have that information. What we can notice as well is that the wall thickness is 3 millimeters and everything else seems pretty fine. So the biggest focus will be getting that pipe in the correct position. If you want to come back to this illustration, mark this time in the video, come back to it, because I will be hiding it right now and putting on my second screen. To begin creating the 3D model, we'll be starting with a sketch. The XY plane for the bottom part. Next, we'll grab a slot over here, drag it over there. We have our width known, which is 54 millimeters. Enter that and click on the line as well to match it. Next, it will give us the radius as well for it. So the total width is 50 millimeters, radius 25. Let's put in there. We'll be seeing some redundant constraints. Don't worry about those. We'll just delete them. Next, we need to make sure that the whole thing is symmetric to middle. Shift click both points and additionally the third line in the middle. Constraint symmetric. Now the whole thing will be symmetrical to the mid. Let's delete the redundant constraints and we have the sketch fully constrained. Great, we can leave now. Let's pad it. We need about 9 millimeters because we're... yeah. After that is done, let's head to the... After that is done, let's create another sketch for the pipe. For that, we'll be going into the XZ plane and creating and adding external geometry. We can do that by finding this button, create external geometry, or with G and X. Let's import 2 of those points. If you can't see them, press the view section point and you should be able to see the imported lines over here through the geometry. Next, we need to create an approximate location for the pipe. This doesn't need to be perfect, so we'll just eyeball it currently and then constrain with some tools. Again, we have some redundant constraints. Let's remove those and start working with the geometry that we have. First, what we'll do is constrain the angle. Select the dimension tool, select one edge, another edge, then it automatically knows that we're looking for an angle. Let's put in 90. Next, we have another angle in this scene, so let's find the angle that is located from the red axis, and that should be 33 degrees. There we go. Now, that's good, but there's a problem. It's skewed. Don't worry. We select both of those. We press parallel with P over here. Now you can see the geometry it is much more constrained. Still, not good enough. What we need to do next is limit the height of the whole pipe. So find the highest point, drag it to the right side, so it snaps to the center origin point, and let's type in 65. Now we have added one more constraint, but still we're not done, because there are a couple of more points that are free to flow. The main things here would be finding this position, and that would be 16 millimeters. If I select a point here and another point here, we can type in 60 millimeters, and we have constrained it from the edge. So now the only edge that moves is the furthest one. As we can see from the drawing that the pipe's length is 35 millimeters, diameter, we can press on the dimension tool, drag it out, and type in 35 for the diameter. Now we can see the whole thing has lit up green, and we're ready to leave. Even though we have the whole geometry over here for the pipe, we'll be creating a datum line to create an extruded pipe. For that, we'll be selecting the top longest piece, and over here, hovering over datum plane, create a mesh. If it doesn't show you perpendicularly to that edge, find the edge unlined reference over here, click around, you'll figure it out. Once that's good, let's press OK, and we have our datum plane. On that, we create a sketch. Good thing we already have one point, but we'll go in here and create the circle, which is 35 millimeters. 35, and click OK. We have to have it symmetric, so let's click in on the dimension tool. That 35 divided by 2, we'll have it perfectly centered over there. So at this point, you should be seeing the circle over here in the air in the specific angle. Once that's good, let's pad it to our object. When you pad it, you might see some errors. Don't worry, because we have not set up the pad parameters fully yet. Firstly, we need to press reversed. Secondly, we'll change the type to first. That will make sure that the pad will only go to the face and nothing more. Currently, we're through the hardest part of the project, so congrats if you made it that far. Next, we'll actually hide the datum plane. We don't need that anymore. Same thing we can do with the sketch. And we have to select the parts where that will be hollow. So let's select the end and also the bottom. With both of these parts selected, we'll find our way to the thickness button and make it thick. Not thick, but like hollow. And we can already see that it's doing a great job. We can see it through. And now we need to change the arc joint type to intersection. So the inner line over here would be sharp. You can see the difference over here. And let's increase the thickness to 3 millimeters as per the specifications of the drawing below. Let's click OK. Once we have the thickness, let's apply the fillets as well. Click on the inside of the 3D model, find the fillet tool. The inside is 3 millimeters, and on the outside we have it 6 millimeters. Great. Now we have the model. We can already calculate the mass of this model by finding our macros, center of mass. If you don't have this installed, you can do it by the add-on manager and finding here center of mass. Might take some time when it's updated. Here you can install this one. I already have it installed. Once you have it installed, you can find the macros and execute it. Here we can change the default value of the density to 1020 kilograms per square cube. Change that to grams because we need to insert the grams. And we have our final mass, which is 37 grams. So congratulations if you've also got 37 grams for your 3D model. If not, please inspect the diagram and see where you went wrong, and slowly, piece by piece, measure where you have gone wrong and try to figure it out, because precision matters. With that, I would like to thank you for watching this video. I really hope it helped you, and I will see you tomorrow. Ciao!